metabolic process. We're breaking stuff down for energy. Now, when energy levels get high, what happens is there is an intermediary right here as you're making ATP called citrate. It's a chemical called citrate. Citrate goes back here, boom, to phosphofructokinase, and it changes the shape of that. That chemical works on another chemical, changes the shape of this enzyme so it no longer functions. It also changes the shape of these two enzymes, which we'll talk about later, so that they no longer function. What happens then is any glucose coming into the system, if your energy state is high, now gets reversed and goes backward and is acted on by something called glycogen synthase. It's linked up like a bunch of Tinker Toys and turned into glycogen. You store about 70 grams in your liver, and you store about 220 grams in your muscle. Okay? Now, that's when you're in a anabolic state, you're well fed and you're at rest. Well, guess what? In contemporary society, we're always well fed and we're always at rest. So you got 220 grams, if you were a 6 foot, 185 pound male, you can store about 290 grams of glycogen. Okay? To keep your blood sugar normal at 80 milligrams per deciliter, it only takes about a teaspoon of sugar to do that, 5 grams, to keep your blood sugar normal. So what happens is, if all this is full and this is inhibited, once that's full, you can't go backwards anymore. Your body protects you against having excess sugar poured into its metabolic machinery. It's like pouring pancake syrup on your keyboard. It doesn't want the works mucked up. So what does your body do then? Well, for one, on the surface of all your cells are insulin receptors. And it says, no more sugar, please. So it starts down-regulating insulin receptors. But your sugar in your bloodstream is now stacked up and high, so your insulin levels are high. But your muscles are going, no, 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 don't want more sugar. Well, guess what's still saying yes, yes, yes? Your fat cells. They retain their insulin sensitivity. So when you're in a high energy state, and like almost every American in this country, your glycogen stores are completely full, the only metabolic destination, you can't go backwards, so you gotta go back this way, but this is inhibited, is at the level of fructose 1,6-diphosphate. You go through a metabolic process that turns that sugar into glycerol, takes 3 of them, tags them together, that becomes triacylglycerol, what you guys know as triglycerides, and it gets stored in your body fat for future usage. Okay? So that, in a nutshell, is the metabolic syndrome. When you are chronically in a high energy state and you cannot store any more glycogen and you're moving it all to body fat, you start doing something weird. You start starving. You are suffering from internal starvation. And I first made this connection when I did a CT scan of a really obese patient. Now, if you look at the flank muscle on yourself, external oblique muscle, its normal thickness is about as thick as this book. But on the morbidly obese, when you do a CT scan, you're cutting little cross sections like a honey-baked ham and looking at cross sections. When you look at their external oblique muscle, it's as thin as this back cover. Okay? And the reason is they are suffering from internal starvation. They eat food, but that food can't go here, it can't get stored here, it can only get stored as fat. Their insulin levels are chronically high. Insulin is a trump hormone. So when their energy levels low, if they go 2 or 3 hours without eating and they start to need energy, well, they got sugar stacked up in their bloodstream that they can't get into the cell. That stacked up blood sugar makes insulin high, and insulin inhibits this hormone called hormone-sensitive lipase, so that you cannot mobilize body fat out of your body fat stores. Insulin inhibits glycogen phosphorylase, so that you cannot mobilize glycogen out of your glycogen stores. Which is why you would think if you were morbidly obese, there would be some sort of negative feedback loop that finally says, stop eating already. But it doesn't. it's actually a positive feedback loop. They're eating 10,000 calories a day, and they're ravenous because it's all just getting shunted straight over to here, and it can't get out. It's trapped. That's the metabolic syndrome. Now, we got to talk about how to reverse that. Okay? Well, the cool thing about us as an animal is that we have evolved this metabolism. And the cool thing about this metabolism is how it can turn on a dime. If you ever watch the Animal Planet, you watch a little springbuck or an antelope, when is it most likely to be attacked?
When it's eating.
When it's eating, right. Or when it's at the watering hole. So here you have an animal that has to be able to go from an energy input metabolism that's all heading in this way. And that's a lot of metabolic activity that's going on. And it's all going in one direction, like the LA Expressway heading in one direction. This animal all of a sudden gets attacked on a dime. It has to turn its metabolism from anabolic to catabolic and do it in a big way. Well, the way that it does it is what we use to exploit, is what we exploit when we perform this kind of exercise. I'm going to lay it out for you. These two enzymes here, glycogen phosphorylase and hormone-sensitive lipase, are how that animal does this. And these are like the mortgage-backed derivatives of metabolism. Okay? They are highly, highly leveraged. And they operate by an amplification cascade. Each of these is a hormone that will act, it has several subhormones underneath it. And hormone-sensitive lipase will activate 100 of its subhormones. Each one of those subhormones has 100 sub-subhormones underneath it. So now we're looking at 10,000. Each one of those has 100 underneath it. So if you amplify, if you attach and hit just one of these, then you are going to be able to cleave millions upon millions of molecules of triglyceride out of stored fat. If you hit one of these, you're going to be able to cleave and release millions and millions of molecules of glucose for immediate burn. Okay? That's how we turn it on a dime. This is built in to our metabolism as part of our fight and flight mechanism. That's what we have to exploit to reverse the metabolic syndrome. Okay? So it requires high intensity exercise that's severe. Okay? But running as fast as you can up a hill may not be the healthiest thing because of the impact forces and stuff. And we'll talk about how we get around that. But getting back to this, what happens is, if you mobilize body fat, it's able to be shuttled back into the cell where it enters directly into the mitochondria, goes through a big process called beta oxidation. And it pumps out not 36, but 96 molecules of ATP. We are evolved to be fat burners. It's in your genome, that's what we're encoded for. We prefer to burn fat. Your brain prefers ketone bodies from fat over glucose in terms of its effectiveness. If you ever really have a big presentation to give and you want to be on your A game, go into it fasted. You'll be much sharper because you're burning ketones, not sugar. Okay? So, we really evolved to be fat burners. So when we hit this situation, we mobilize fat and start burning it for a lot of energy. Okay? Same thing with the glycogen. That gets to get shuttled through here and go down through that process, and we make use of it. But the beautiful thing we do when we perform high-intensity exercise is that we empty out these glycogen stores, and we're allowing or making permissive fat mobilization and fat loss. But the most important thing we're doing is we're emptying our glycogen stores. What happens then? There's a strong signal that that needs to be replenished. Well, how do you do that? By having insulin receptors on the surface of the cell that takes sugar out of the blood and puts it back in there. So what we've done is we've restored our insulin sensitivity. Instead of having 500 insulin receptors on the surface of the cell, we've restored our insulin sensitivity. We now have 50,000 insulin receptors on that cell. So if we get a bump in our blood sugar, that gets mobilized and stored quickly. The other thing that happens is when you do high output